Keep going? Okay. All right. I'm Dale Henrichs. I work for GemTalk Systems, and I think I know just about everyone here. So anyway, my talk is on the light at the end of the tunnel, and I'm announcing GS DevKit Home and tODE for release. When I talk about tunnels, or an end of a tunnel, there has to be a beginning somewhere. And that beginning of the tunnel was about 30 years ago when I started working on Smalltalk. And I was working on a Tech 4404. And one of the things I was doing was doing Smalltalk fileouts to RCS for version control, and then building images from these RCS fileouts from different versions. And today I am working on storing Smalltalk to Git and building images from the Git repositories. So it's been a fun 30 years, but I think I'm about done. With this release, yes, then I get to move on to other things. Let's see. So GS DevKit Home and tODE. GS DevKit Home and tODE provide an open source development environment for Gemstone S64 from GemTalk Systems. GS DevKit Home and tODE, did I just duplicate myself? Yes. Preserve, the idea is to have a Smalltalk development environment in tODE that preserves the image-based development experience while adding disk-based persistence, which involves interfacing with a disk, which is not something that regular Smalltalk programmers do very much when they're working in images. Allow you to store workspaces and share workspaces between multiple images. And in Gemstone, an image is, I'm going to call it a stone, so I'll be interchanging that. And also do automated image building. And that's all part of, this is all an integrated development environment that works from disk to image and out and back again. So to start with, I'll just say a little bit about Gemstone S64. It's a multi-terabyte Smalltalk image. It can be shared by hundreds of Smalltalk VMs and thousands of transactions, which are image saves in Gemstone terms per second. And we have a generous free for commercial use license. So it's something that, as a small business, can start using Gemstone and turn themselves into the next JP Morgan. So GS DevKit Home is a collection of bash scripts for managing and creating Gemstone stones. You can do a create stone, a delete stone, start stone, stop stone, an upgrade stone where you're taking your image in one version of Gemstone and run a script to now upgrade to a new version of Gemstone and have your application running in a new version. And then stones lists available stones in your system. There are about 30 scripts that are involved in GS DevKit Home, and these are the most interesting right now. If you've ever tried to use Gemstone, you may have had an interesting time of it. So finally, you can install Gemstone in 5 steps, and 3 of those are defining an environmental variable in your path. So you start by cloning the GS DevKit Home repository up on GitHub. Then you set up your environment. The GS Home points to the home directory of your installation, and you export your path. Then you run the script install server client. All right, it creates a stone named DevKit 329, a client, tODE client, and for version 329 of Gemstone, and then you run the start client tODE 1. This install server client starts the stone, installs tODE, and gets everything running for you. When you get a tODE client, you're given a little system menu that has a list of the installed stones there that you can choose from. So you choose your stone and decide which one you want to connect to, and you come up in a tODE environment. Now, I'm not going to talk a lot about the tODE GUI today because I want to focus on the deployment and sharing aspects. But what you have when tODE is a system menu that basically gives you access to the generic Smalltalk GUI applications and a tODE shell. And I'll talk more about that, but basically you have a Unix-like shell where you type in Unix-like commands and you run Smalltalk programs from there. Now, like I said, I wanted to, this is a system of sharing disk-based multiple stones in your development environment that's all coordinated to work together. So what we've got in tODE, and tODE stands for the Object-Centric Development Environment. We have a virtual file system, and what that is each tODE image has an object directory structure based on objects. But you're able to have links down onto your disk structure. And that means that you can basically seamlessly move from inside your image to disk, and in the future to another image, to another disk, to another image, and on and on. And then the GUI, like I said, I've got classic Smalltalk tools. The command line interface, the tODE console with a bash-like syntax, and the project management, PM. Project management in tODE is based on Metacello projects and uses Git. And the development environment has Git built in from the get-go. So as I mentioned, the VSS object-based file system, and the disk structure is what's used to share objects and scripts between stones. Each stone mounts a common set of directory structure, and then through the VFS, you can go access that directory structure. What's interesting here is I mentioned objects and scripts, and in reality, scripts are objects. So, and they get written to disk in stone format. So a .stone file gets written on disk. That's using stone serialization format. You might be familiar with that. And when the VFS encounters a .stone file on disk, it reifies the object and then allows you to do what, now it's an object in memory that came from disk, and then you can do things with it. Show you a little bit more about the virtual file structure here. So the things in blue are purely object nodes in the root file system. The things in yellow have mount points to the disk, and I'll talk about what those mount points are. Underbar home is a pointer to the environmental variable GSHome that I talked about earlier. And so from here, you can do cd to /underbar home in the shell script and view the entire disk structure of your project. Home is the place where shared scripts and objects are stored. And if I had more time, I would actually tell you what a home composition.stone does, or I'd show you what it does. But what it does is take multiple directories and composes those directories into a single directory. And so basically, I'll get into it a little bit more. And projects does the same thing for projects, and I'll talk about project entries in a little bit. The directory structure that gets composed by these composition objects is a default structure, where the default structure is what I supply. My supply, what GSDevKit Home supplies as default scripts and default project entries. The local structure is where you put overrides to the default structures or additions. And then the stone structure is where you put stone specific. So the local structure is shared amongst all stones in the system, and then you have stone specific overrides and extensions. So this allows you to make changes to things in the local structure that is then shared by all objects, or all stones in your system, or copy an object or a project entry to the stone directory, and then do work on that just for that specific stone. And the stone / is basically a symbolic link to the current stone. And so it's convenient to write scripts that talk about /sys/home or /stone to talk about the current stone without having to know the name of the stone. Mentioned the GUI, and I just put a couple pictures up here, and I recommend you download GSDevKit Home if you want to see how this stuff works. But this is a class browser, and this is an inspector. And if you've seen other presentations on tODE, you'll know I've taken a different approach to the GUI, slightly different. Although you may not be able to see this, but I've actually got an instance in class button on my class browser now. So that's new to you guys. So I showed you this. The command line is for custom tODE scripts. And in tODE, that's a list of all the commands that are available in the command line system. There's 160 commands there. So this would make one heck of a system menu in a regular Smalltalk image, all right, to look up 160 commands. And that's really, the advantage of going with the CLI is for running Smalltalk programs, all right, because it isn't practical to go around and take 160 pieces of functionality and find a spot in a GUI somewhere to put them. The other thing is menu picks are invoking commands of those 160 commands. So all menu items, all right, but you put the frequently used operations as a menu item. And then every menu item in the system should have an equivalent command line invocation. So if you've ever gone around and said, all right, let me tell you how I reproduce the system. Open the browser, find the class, click on the blah menu item, click on the next blah menu item. Now, and you've got this whole sequence that's difficult to describe to other people, let alone put into a script and do a reproducible operation with that. And in tODE, it's relatively trivial. So that's what you do. You can bulk. So the rest of the commands, the 160, are things that are useful things to do in Smalltalk, but don't necessarily fit into a particular GUI or menu item. And so most importantly for me is this gives you a consistent way to script batch jobs, all right? And you can call tODE scripts from bash. So this means that you can run a command through the menu item. You can run the same command at your command shell script, write scripts as a function of that command, and then run those scripts from a bash script, all right? And that means you can do just about anything in your create stone command for your own system that you could do, running menu items. So I think that's, to me, this is just a very important thing. This is an example of a command that maps to a menu item and maybe a better view of the class browser. But the command is browse class --full, which says give me a full view of the class, which is a full class browser. Without --full, you would just get this pane here. --exact is don't use a regular expression, and open it on the tODE Metacello tool class. And that opens that window. There's also menu picks that do the same thing. This is an example of something that is a command that's not regularly used and hard to put into a GUI, is browse the diff between version 117 of the configuration of Greece and the method version 116. All right? This is doing a diff between two arbitrary methods in the system. All right? And that's relatively straightforward to do. It's not something you can easily put onto a menu item when you have the entire system to pick from. But as a user, knowing these are the two methods, I can write this command and very easily come up with a diff view. So I picked Greece or configuration of because this happens to be one of those nasty things that you always wonder about when you're using Metacello is, what's the difference between those two versions? What changed between those two versions? And there's really no way to get that. And about the fourth or fifth time that I did that manually, digging through the system, trying to figure out what Smalltalk API do I call to create this window, I wrote a command to do that, and the rest, and just continue doing that. So I've mentioned Smalltalk programs here off and on, and scripts, and to me this is one of the great mysteries of Smalltalk for someone that's new to a Smalltalk environment is, how do I run a command? How do I run a program? Where's my Smalltalk program? All right, and what would be a Smalltalk program would be, a command, some arguments, and then execute Smalltalk code. All right? Well, so I've done that for tODE. And this is an example of, if you run touch shell home example, you create a template shell script for tODE. The sections up at the top here is Topaz is the command, the command, the central server. Object in. If you're familiar with Bash, Bash is byte stream in, byte stream out. Well, this is an object shell. What the heck would we be doing bytes for? All right, let's put objects in and objects out. All right, and that is a natural way to do scripts in a Smalltalk environment. And then we have a command object, and the command object basically represents the command line. I got to get something to drink.
generate a bash script out of this?
No. This is just a Smalltalk program, and it executes in tODE, in the tODE environment. So it's just like doing a do it. In fact, this little section right here, this is a do it. All right, and so the difference between a classical Smalltalk workspace and a Smalltalk program or Smalltalk script is I can take arguments. All right, so how many times do you have these workspaces where you've got all your local variables at the top in temps, all right, and then a big bunch of chunks of code sprinkled throughout the system with comments telling you where to select, all right? And the way that you invoke your Smalltalk program in a workspace is edit some of the temps up at the top, do it there so you set it in your workspace variables, then go down to the chunk of code that you want to execute, carefully select it, and run it, all right? In this environment, you use command line arguments, like in this example, this is where you define where the command line arguments are. In this case, it's help. This is the shortcut key. You can do none, required, or optional. So you can basically define input parameters, whether they require an argument or may require or not. And what you produce is a dictionary of options. And the keys to the options are the parameter name. If absent is what you do by default. And if present, you go in, and in this case, it's the help menu item, or the help option, and I have a template for generating a man page. So this is the other great mystery of workspaces is, where's the documentation for Smalltalk, all right? You go find the class. All right, so I have 500 classes. Which class comment do I look at to do X, Y, or Z, all right? So the Unix had the same problem of how do you document the system, and each command self-documents with a help statement. So to run this script, which I created in home example, which is actually in a shared directory structure, you type home example -H, and it runs the program, which gives you the man page. And down here would be the examples of using it, and in this section, the types of stuff that you can do. So again, this is like, workspaces have been around from the beginning, and they've been a pain to use from the beginning. They've been a pain to share from the beginning. And, I think this model of creating I think it's a Smalltalk program that you run in your Smalltalk environment. So it doesn't run in the Bash universe, because this is not Bash. This is an object file system. This is, Smalltalk. Just with a, command line, veneer. The next part I want to talk about is project management. Said before, it's Metacello based. And what that means is the Metacello project is the focal point for your standard operations. You load a project, you do diffs or different changes within the system for Metacello project. You commit a project, which means all of the dirty packages as part of a project get written out at once, committed with the same commit message. And you can browse things within, browse the dirty packages, browse the packages, browse the classes, categories, etc., within a Metacello project, because that's kind of the big unit in the system. You can also do git, push, pull, checkout, branch. And again, if you're familiar with Metacello and the GitHub model, where you have a GitHub URL to reference a GitHub project, and you can do a download of that directory structure for Metacello. And what happens with Metacello is that particular directory structure, all the packages that are part of that version, are managed by the project. And so they're all loaded together, and all of the packages you need are on disk. And so using git, pull, checkout, and branch, you can traverse from within tODE your git process. And then the final thing that, besides git, that really makes this hang together, as far as I'm concerned, is a thing I call a project entry. So when you load your system, all right, so I guess the Smalltalk universe is full of workspaces that go something like, go for new package configuration of blah, load. Well, that's a workspace, right? That's a do it. That's not, how do I build my image? Now, you can create configurations that build your image, but these are all Smalltalk based things. All right? You have to have a Smalltalk image booted to execute those things. So how am I going to bootstrap a system from scratch? And that's what the project entry really was invented for, was to add additional information. And project entries are stored on disk and shared. So if I have a project entry for Seaside, that's my specification for how I want Seaside treated within my universe. And every stone that I create, if I say load Seaside, the project entry is used. So I'll back up just a bit and just show this is the project. In fact, I'm going to back up quite a bit because I talked more about the project entry than I wanted to. But basically, this is the project list. And each one of these is a Metacello project. This is the SHA of the Git commit that was used to load that particular project. And this is the name of the branch or tag that's associated with that commit. So this way you can really tell exactly, and I mean exactly, what's loaded in your system. There's no question about what's there. And then, as I mentioned, you have all those menu items to deal with. Now I'll get a little bit more into the project entries. So I mentioned before, /projects is where I have the composition of projects for your particular stone. So if you do an ls of /projects, you get a list of these things. Now, if you're familiar with Gemstone, Glass 1 is the glass package that has the compatibility layer. Grease, GS Application Tools, is for running servers. GS DevKit Home, you're inside an instance of that. But anyway, these are the projects that are available for load. Some of these don't have to be loaded, all right? Because this is looking at project entries that are written to disk. So you're basically making a specification of what, if I was to load Zinc, what would I do? And I'll use Grease as an example. So here, I'm editing /projects Grease. And this is what you see. You're creating a Smalltalk instance of a Smalltalk object. The stuff in blue here is, if you're familiar with Metacello, that's your Metacello load specification. All right? In yellow, this is your what's called an install script. And what that means is if I run the install script for this project, it's going to clone the Grease repository. Or the Grease, it will clone Grease from the GitHub GS DevKit Grease to your local disk. And now you have a Git repository on local disk as opposed to a download of the directory structure. And that means you can save things to the Grease repository, load them, move them along, choose which version of Git you really want to use, and then lock it in. Because this is one of the things that starts happening, is happening today in the Smalltalk community using packages and configurations is configurations are not necessarily static things. There's like a stable release, a stable version that rotates and slides depending on the vagaries of the developers of the particular project. With Git, I pull down a particular commit and it stays that way until I change it. So when I'm ready to change, I can do that. So I'll just, so this is just a quick overview of, when you do a project load Grease, the Metacello expression is performed. If you do a project install Grease, these commands are executed. You basically clone the repository. But that clone script is user settable. Whatever you want to put in there as part of the install instructions can be done there. And that's where you customize your project entries for how you want to deal with Grease. What things do you want to do there? And one of the common things I do is put tODE scripts as part of the project and then mount the directory that points to the tODE script into my /home. So I can run scripts for Grease within my environment. And it's on disk, so when I save those things on disk, it'll be saved to the Grease repository. You can create a project entry and just, this is an example project, or it's external, but it's an example project. But this basically just creates a brand spanking new project entry for a brand spanking new project. And by the way, if you're creating a new project, there's a project new command that generates all of the pieces that you need for the tODE pieces that you need, which includes a project entry, a baseline of, it creates a Git repository, and I think that's about it. And the other thing you can do with the project entry is you can download it. So I have a GitHub I/O site up on GitHub with a selection of projects with predefined project entries. And this example would be seaside3.stone. So project entry --Earl downloads the project entry to your shared disk area. You can edit that seaside3.stone and decide how, within your environment, what do you want loaded for Seaside? Do you want it cloned? X, Y, Z. All right? And in fact, I have an instance of a class there, right? And that class has behavior. If you have special requirements within your system for, I have preload, postload, in the middle of load scripts that I want to run, just subclass TD project entry and add your own behavior, your own fields, and you're off to the races. So let's see. I think, I ran ahead of time. So I say give GSDevKit Home a try. If you've tried to play with Gemstone in the past and ran into a brick wall, give it another go. Give it another go and find out what kind of things you can do with, a different kind of Smalltalk development environment. So, ready for questions? Yes, sir.
You said I'm almost done. What's missing?
You mean?
When you said
yeah.
the person is almost the
You mean the
tunnel.
I'm not out of the tunnel yet, am I? No. So, yes. Well, finished. Is any software project finished? All right? No. And what goes on here is, I have tODE is functional at this point in time, fully functional. But how many, I think I can count on the fingers of two hands how many developers have actually used tODE. All right? And I know personally I have probably 6 to 9 months of projects, improvements for tODE that, are on my to-do list without hearing from more developers. All right? So that's the part where, what I feel with tODE is the architecture I'm very happy with. All right? And, and to talk about, is it done? These .stone, this download the Stone projects from GitHub I/O, that was conceived of a week ago Sunday, trying to solve the last little piece. And I think that actually solves the last little piece. All right, because now I think it's a complete system. And like I said, the architecture works well. I think it works well. The GUI, I have the icon, or not iconic, the non-iconic Smalltalk GUI, individual windows instead of a monolithic pane. But it's a thin client. The GUI can be built. It's real simple for me to do it, and I don't have to build a complex client, model. But it can be done. And does it need to be done? Yeah.
The commands that you showed,
Yes.
they open graphical interfaces.
Some of them do.
Do you have any command that just outputs text that can be parsed by another tool?
Actually, the shell, all right, is going to be object in and object out. Okay? So it's not passing text back and forth. So your programs within the command line are taking objects in and then dumping an object out the next command can process. So, but, in terms of arranging to connect to another service, yes, all right. If you're talking about what you want is to list something in a bash shell that then gets piped into something else, this is kind of the area where I go, this is, I think there's interesting things that can be done there. Okay? So, because this is all, this is all Smalltalk, all right? From the top to the bottom. So it's just a matter of figuring out how we want to do that. And I've actually got that as, one of the items is how do I manage, text output versus object output, because there's times when you want one or the other. So, yeah.
Maybe you just answered it. I'm not sure, but
Yeah.
do you think the kind of bash
Yes.
also with typing these things, so like you type objects
Yes, within the question is, do you take the Unix-like piping idea and do you actually pipe objects between commands? And the answer is, I do have a pipe. You can put a pipe into a series of expressions, and it will feed object out to object in. But I decided that objects are so useful that I don't want to have to pipe. So I have a late binding on whether. So that means that I have a stack of objects that get produced by each command, all right? And the top of the stack is fed as object in to the next command. So you do piping, and you don't have to put the pipe in and think about it ahead of time. So, yeah.
My favorite topic with tODE is, you have tab completion yet? You've got 160.
Yes, I have tab completion.
You have an alias.
I haven't added alias, and I haven't added environmental variables in the tODE shell environment. And this is the area about being complete, all right? Because I look at, the bash shell. It's been evolving for 30 years, all right? The Smalltalk shell didn't start 30 years ago. So there are things, the evolution that should happen. And by the way, I do want to mention that projects or commands are looked up in a dictionary of commands by the primary name of the command. And so we do a dictionary lookup, and there's an API of what's expected to get back from that dictionary lookup. But that means that you can go in and define and customize how the project tool works. You can override commands because the basic sequence within tODE is that from a command, you parse the command and call a Smalltalk API. From a menu pick, you pull the objects from the browser that you're sitting in at that menu item and then call a Smalltalk API. All right? So, that fundamental architecture of everything has a Smalltalk API, and I can access that Smalltalk API by saying, give me the tool instance for the project command. And now I've got an object that has guaranteed that it responds to that API. And then I can make the calls. All right? And if you go in and change how you want a browser to work, and you override the browse command, every single place in the whole system, because nobody's supposed to access classes. They do lookup by the browse command to guarantee that you get the same API. And that means that if you do override, that behavior happens everywhere within the system. Okay? And so like I say, I think that I'm quite excited about the possibilities here, but it's only, I would rather say it's a new tunnel. There'll be a little bit of daylight and then into the next tunnel. So, any other questions? Yes.
I run Shemson 3.1.
Yes.
So I want to update to the latest version. There's a script to update the stamp to all objects.
Yeah, so if you'd like to, so what you're asking is, can you upgrade from Gemstone 3.1 to 3.2.9? And the answer is yes. Okay? And the basic sequence is there's several things that you have to do to upgrade a Gemstone system when you're doing an upgrade. But for these kinds of upgrades, what happens is the upgrade Stone script that I mentioned earlier takes you through bootstrapping Stone or tODE because I know what's going on. So that code gets loaded, and then you have an option on the upgrade Stone command to pass in a script that you want to run to install your application. Okay? And so really the way I recommend that people do things is they do upgrade my application script that they put into the bash script where they put in the commands that they want run when they do an upgrade. And you actually sit down and put that into a shared spot that you then share with everything else in the system and go on. But yes, that now works. We've done lots of tests with this with that particular feature. So yeah, you can take 3.1 and get to 3.2.9. Have to write some scripts. So, you have questions? All right. Thank you very much.